Good evening.
Good
Can you
evening,
hear me?
sir. Yes,
Okay.
sir.
Right. You are the student, huh?
Yes, sir.
Right. Okay. Here we are going to start the session. I'm starting from topic 4 that already you informed that. What about the
Yes.
earlier topics?
Uh, in my other class, they just started topic 3, so I wanted to go ahead with topic 4 to complete the
Okay.
syllabus fast.
Right. Okay. Then I'm continue from topic 4. Then I will complete the topic 5 also. After that,
Okay.
then we'll discuss some more past papers according to the time. We can arrange the past paper discussions also. Right.
Okay, sir.
Uh, right. Okay. Uh, Here that in this class, I am using PowerPoint slide presentation. Then I provide the note also, an
Okay.
activity sheet. Right. I
Okay,
will,
sir.
yeah, I will pass that documents to you later in this session today. The first I want to share the presentation. Right, this presentation is
Okay.
interactive. Interactive mean sometimes I'm assign the question, then you have to give the answers through the same presentation. Right, then while
Okay, sir.
doing the presentation, you will understand how to do that. That first I'm sharing a link, then through the WhatsApp chat box, sorry, this Zoom chat box. Then you can click on the link, right? Once you click on that link, then you can join with the presentation, right? Then
Okay,
first
sir.
step, we are going to do that, right? Wait until I am sharing the link. If you are having any thing to doubt, so then not understanding the thing, then please tell me.
Okay, sir.
Right. The link is available now in the chat box. Now open your chat box in your computer, then click on the link. At the same time, I am going to share my screen. The presentation also available in my screen. Uh, yes, now you can click on just click on the link. Then there is a small images there, then skip it. Still not click on that link.
It's loading, sir.
Right, click on that link. Right, why is there any issue or problem?
I just signed in.
Right,
Um,
okay, now you are joined, right?
okay.
Right now, I am going to start the class. Right here in the same presentation, now you
Okay.
can open in your device. Here, the topic we are
Yes.
going to cover, the computer. Right. If you are having any trouble or anything to not understanding, then please ask me. Also, you can use the chat box, right? If you are having
Yes,
any,
sir.
then you can communicate through the chat box, right? Okay, here the first slide about the regarding the topic for computers. Right now, moving to the first thing. about the computers. Here, the first thing we should want to identify what is computer. Right. Before that, I am going to show the note also. This note I will be shared today itself. All
Okay,
the
sir.
detailed note available in here. Right. Once I am
Okay.
explained, then after that you can go through the note. Then you can understand it here. Right. Here the today's note. Not going to cover all the things in here today. Right.
Okay.
However, you can get the this note for the next week also available this note. Right, now moving back to the presentation. Right, here giving some idea about the computer. Actually, before moving to the technical part of the computer, then you want to understand the basic process of the computer. It is very easy. There are three steps in the basics process in the computer. In any computer, having this process, what is called input, process, and output, right? That we can define computer as an electronic machine or data processing machine. That's the most more common definition is data processing machine. Data processing. That means if you want to process the data, need input. After processing, you will produce output. That diagram. Look at the diagram here. Input, process, output. Any computer having this process, right? Uh, there is a input process. Then once you input the things to the computer or machine, then processing activities happening inside the machine. After processing, it will produce the output. The output mean the meaningful things, right? Then look at the example here. Right. Then try to understand this example. Input is here that what the input number 3. They are going to input the 3 here. Once you input this 3 into the machine, then processing. Right. There are two processing thing here. One is multiplied by 2. Then after multiplied by 2, then should add 2 again. Then 3 into 2 means 6. Right. That here the process is available below that. Then out again at 2, and finally it will get the 8, right? 3 into 2, 6 plus 2, 8, right? That's the simple process happening in this example here. That below that it will explain in it. Input is 3, then process 3 into 2 plus 2, output 8, right? Here it giving some simple explanation. Input data, then process and information of output. Information input mean the things available surrounding the computer, right? It may be data, right? Numbers, text, images, video, right? Anything that may be input. That first you want to input, then process, right? The process. That machine work according to some rules, given rules. That's the process. Right? In this case, the rule is 3 into 2 plus 2. Right? There is a that machine should work based on a rule. Right? Then it will produce the output. Output is meaningful output. Is it okay that understand the process here?
Yes, sir.
Sorry?
Yes, sir, it is clear.
Right, okay. Right. If you are having any trouble not understanding things, please stop me and ask, right? Okay.
Okay, sir.
Then detail of this explanation available in the note, right? Then I am again back into the note here. The once I provide the note, then you can go through the note here also. The same thing
Okay.
available in the note also, right? Okay, now moving to the second slide here. Right, now your turn. Write down the input, process, and output, right? Then here there is a two activities. The first one, the input that decide what are the input, then process and output, right? Then separate place available in your device. to write down the answer. And in that place, please type input, then put a dash and type the answer. Then write down process, put a dash and write down the process. Then write down input, then put a dash and write down the output. Then try to do it in yourself.
Okay, sir. Okay, sir.
Right. Here now, I can see your answer. Right. Yeah, take your time and complete it.
Okay.
Right. Uh, right, we'll see the answer here. Right, here the input is 3 and 5. It's clear, 3 and 5. Then after input this 3 and 5 to the computer or machine, then first it should want to calculate the 3 plus 5, 8. And again should add another 2, then 10 and minus 3. Right, that's the process. Right, in your case, then look at your answer process 3 plus 5 plus 2 minus 3. It is correct. The output 7. That's the very simple one. I think you can understand it very easily. Right, now try to do
Yes, sir.
the second one. The same place you can use by using the enter key, you can get the space. Find the area of rectangle. Then yourself, you have to decide what are the input, uh, what are the process, what's the process and output. No need any numbers to put here. Just write down what is input, what is process and
Okay.
output. Then first try it yourself. Right, good. Uh, Here, the problem is that AB is okay. That's the parameters. Then you have to justify here. What is A, what is B? Because the rectangle given, that given problem is to find the area of rectangle. Then what is A here? B. Normally, a rectangle, the area of the rectangle, you can calculate by multiplying width and
Mm,
height.
right. Yes, sir.
Height and width. Then A should be width, B should be height. In that way, you have to give the meaningful term for this A and B. Right?
Okay.
Is it okay? Is it clear?
Yes, sir.
Right. Okay. Okay, that's good. However, the logic is okay, correct, right? AB, A multiplied by B, AB. Right, now moving again to presentation. Now next slide. Here we should want to follow up the range of computational model, right? That means that earlier we identified the process, input, process, output, right? There are some computational model that follow this process. Here mainly, we are going to identify three models. All of these three models follow that input, process, output model there. Right here, there are three range here: sequential, parallel, and multi-agent. That's the three types of computational model. Actually, types of computers. Right? These are the kind of computers that follow input, process, output theory. Right, here the first try to understand this one, sequential computer. It's very easy. The sequential mean one after the other, one after the other. There's must be a sequence there, right? The first, you want to follow the first step, then second, third, like that sequence, right? Then you can't follow after doing the first step, then you can't jump to the third step. without doing the second one. Right? Once you do the first step, that you must do the second, then third, like a waterfall. Right? That it must necessarily follow the line by line or sequential process there. That kind of computers known as sequential computers. Right? Is it clear that point?
Yes, sir.
Right. This diagram explain it. That look at the arrow pointing. Always this arrow point in the next step. Right. Next, there is no arrow to upward. Only the downward arrows here. Like climbing the steps. Right. That one steps you move, then you must uh, do the second step. Right. Then third one. Right. There is no way to jump in it. Right. If you are trying to jump in, then where is problem? Like that sequential computers. Right. Based on that, now try to do this activity based on the sequential computers. Right. Here the MCQ type question, model question. Which of the following best describe the sequential computer? Right. According to your understanding, try to give in the one answer. Just touch it. Your answer. Take your time and think. Right. Here your mark the second one be a computer that process instructions one at a time in a predefined order. That's correct, right? That's the answer. Predefined order, right? Must follow this instruction one after the other, right? That's the definition for sequential computers. The other answers are not relevant with the that definition, right? Okay, good. Then another activity. Right. Then look at this one. This is a past paper question. Look at the year 2022 May question 1D part. Right. Now try to do this one. Identify which one of these describes a sequential computational model. Right. Then you're giving the answer. Yes. Program instructions are executed one after another. Yes. Correct answer. Right. Very good. Okay. These other answers are not relevant. There are some other definition. The only the relevant one is the answer D, one after another. Right. Okay. Then back to the presentation again. Then we can learn in that way one model question and the also past paper question. Right. Most of time I'm trying to use the past paper question for the theory. Right. Then you can understand better. Right. Then next one, that earlier we identified the three types of computational model. The first one, sequential model. Then second one, parallel computer. So parallel model, right? The different parts of the program are run different processes. I think you have little idea about what is processor, right? Processor. Normally in a computer, processor mean CPU. That's the most important part of the computer, like brain of a human. Right? Once you assign task to the computer, the CPU is the unit that take total responsibility of doing that task. CPU is the unit that takes total responsibility of a task. Like our brain, once assign a task to us, then we are controlling that task through our brain. Right? Then CPU. Later we'll learn more about the CPU for the understanding. Is another name for the CPU is processor. Right? Processor. What is happening in the parallel computers is they are using several processors, more than one processor. Normally in a computer, having only one processor. Earlier, the sequential type, having only one processor. We are using sequential type computers that normally in your home, in my home, normal people using mostly the sequential type, not the parallel computers. These parallel computers using for special purpose. Right. Then what is happening there? Uh, Here, look at the diagram. That problem you can divide it into several sub units called tasks. Task 1, task 2, task 3, like that. Right. Then each processor assigned to each task. The thing is here, all the processors are working at the same time, right? But different tasks. That means more quickly you can finish the work, right? That because of this parallel processing technology, you can finish the work more quickly, right? That the problem, then subunits there, each unit having a different processor. This processor one is different processor two. Processor three is another one. But all these processes are working in the same problem but different tasks. That is called parallel computing. Right? Is it clear that point?
Yes, sir.
Right. Okay, now moving to an activity. Uh, then in yourself, no need to write down the things. So if you like, you can uh, get some short notes. So in that way, some diagrams you can draw it. The notes are available in the note. That again, I am showing that note.
Okay.
Right, now a discussion. Give me 1 minute. Right, okay, back into the lesson again that I'm discussing, showing that knot. Right, here the sequential one, then parallel computing. Right, uh, in here by looking at by reading this area, then you can understand it. Then also I'm giving the this PowerPoint this presentation also. Also the
Okay, sir.
recording also the this class is record. The recording also I'm delivered after the class here. Right. Okay.
Okay,
Then
sir.
back into the presentation. Now do this activity, model question. Right. Try to do it yourself. Right. You gave the answer, a computer that has multiple processors working simultaneously on a different parts of the problem. Right. That's the correct answer. Right. Answer B. That's explaining what is parallel computing. Right. Okay, good. Then move to another activity. This one is a past paper question. 2022, May question 1D. That earlier one, I think the question one E or something like that. Here, don't worry about that question number. However, past paper question. Right now, in your space, you can write down the answer. That first try to give an answer in yourself. Right. When you write down the answer here, better to mention the CPU 1, CPU 2
Okay.
like that. Sorry, yeah,
So what
CPU 1.
comes in CPU, like the other rows in CPU one?
Sorry.
What comes in the other two rows in CPU1.
Yes, that's the thing. I asked you to think and write down. That's why giving a little time to do that. Here the statement. Now look at the here. Statement is this expression 5 into 2 plus 4 into 3 minus 24 divided by 4. That's the whole task. Right? The parallel
Yes.
computing say what? Here in question say parallel to execute instruction. There are two CPUs here, CPU1 and CPU2. They are getting different tasks. Example, CPU1 calculate 5 into 10. The same time, CPU2 can calculate second term here, 5 into 3. Right? Then CPU1 again can calculate another term, 24 divided by 4. Right? Like that.
Yes.
The first, you want to identify the subunits, so tasks. Tasks separately you
Okay.
can identify. Okay. Can you understand
Okay,
that?
sir. Yes, sir.
Right. Yes, okay, that CPU one, that 22 minus 6, I think, here.
Oh, yes,
Get the
sorry.
point? See, under CPU one in your answer. First one, okay, yes, now okay. Uh, then another, one more process need for CPU two. Okay, okay, yes, two process are okay because 4 marks allocate, one for each.
Okay.
4 marks allocate, one for each, right? Two process for CPU 2 and two process for CPU 1. Right? Is it clear that problem?
Yes, sir.
Right. That's for the parallel processing. Right. Okay. Move to the next slide. Then now tell me some feedback that I'm fast or that it's okay this speed. Can you understand what I'm
It's
saying?
okay.
It's okay
Yes,
this
it's
speed.
clear.
Right.
Yeah.
Okay. Right. Okay. Then move to the next slide. That's the third type that earlier we discussed about the sequential, then parallel. That's the third type of computational model, multi-agent. Right? Multi-agent, actually this name provides some meaning there. Multi-agent is the based on AI technology, artificial intelligence, right? That Second one based on the parallel computing technology. First one sequential. This one AI, artificial intelligence. That agent mean some unit that created based on the artificial intelligence technology. They are having features. This agent having some features similar to humans. Right? That look at these features here in blue color, giving these features that it says agents are independent, right? Make its own decision like humans. As a humans, we can make our own decision. That's independent. Then another feature, autonomous, right? We can control actions in ourselves. We can control our actions, our own actions. That is autonomous. That similar feature available for the agent also. Then agents are cooperate, right? Work together by talking and coordinating. Right? One another feature available for the agents. They can communicate with the other another agent, right? Like humans, human can communicate and work together. Like agents can communicate and work together. Right. That's some features of the agent. By using these features, they are doing tasks. Right. Then look at the diagram. The problem divided that like earlier task one, task two, task three, task four, like that. Each task assign an agent. The second technology, the second type, assign a processor. The processors are not able to communicate with each other and do the work. But agent are able to communicate and coordinate with each other and complete the work. Right? That's the difference. Therefore, agent, but based on the agent, they can do some work not only quickly and they can finish it very quality. Right? That's the uh, one advantage of using multi-agent or agent-based system. Right? That's the third type. Is it clear that point?
Yes, sir.
Right. Now move to activity. Right. This is a model question. Which of the following best describe a multi-agent computer system? Right. Try to answer. Right. Here you gave the answer. A system where multiple intelligent agents interactive to solve problems collaboratively. Yes. That's the correct answer. That earlier mentioned in the definition also. Agents, different agents, they can work together to work, finish to work together collaboratively. They can work. Right. That's the correct answer here. Right. Then look at this one also. Exam type question. Identify the computational model in which several computer systems work together to achieve a goal. It's the last year, to 2024 May, question number 4. Yes, that's very easy. Multi-agent model. Multi-agent model. Right. Right. Then hardware part. We are going to start the hardware. That earlier we learned about the common concept of the computer, input, process, and output. There are some activities that before starting the hardware part, that better to do some activities. Therefore, I'm going to deliver this activity sheet. Right, actually from next week, I will
Okay.
give this activity sheet somewhat earlier, then time to get some printout and to ready. Okay, no problem for this sheet. This one for this activity sheet, there are some question for the next week also, right? Therefore, in your case, try to get a printout and to prepare. Right, okay, then
Okay,
first
sir.
I'm going to share this activity, then we can discuss it, right?
Yes.
Right. Open your chat box and click on the document now I'm shared. Okay, is it okay?
Yes, sir.
Right. You will open this activity sheet. Right. Then you have to do in this say this one. Uh, then in yourself using a actually in if you are having a printout, then you can do that from next week. Right. Then tell me the answers. Right. We are not going to discuss all the things that you can do as the homework, the remaining one. Right. Then okay, are you okay with the document?
Yes, it's still downloading, sir.
Still downloading. Okay, see, it will be downloaded. Then look at the screen
Okay,
here.
okay, sir.
Right. Look at the screen. Then first one, calculating the area of rectangle that already we completed that part.
Yes,
Right.
sir.
Then later you can insert the blanks here. Right. Then look at the this one. Determine right this ATM cash withdrawal system. Then what are the input? What are the process and output? Give me one input, one process, and one output.
Uh, PIN number.
Yes, pin number. One input is what the most important one, the pin number. Then tell me another input.
Uh,
Amount required. Okay?
okay.
Amount required. Uh, then also the language, the account type, right? Saving no current account like that. You can give in the information to the system. These are called uh, these are called inputs. Then process. Then tell me one process.
Um,
Right. That one process is here. What? Comparing. Right? That one process is compare the amount you are asking to withdraw with the available balance. Can you
okay.
understand that?
Yes, sir.
Right? They are compare that machine going to compare you are asking amount with the balance. One process there. Compare. If it is okay, right? The asking amount is in the account, then what happened? They are deduct your asking account from the balance. That's
Yes,
another
sir.
process. Deduct. One process is compare your amount and the available balance. If it is okay, then another process deduct your asking amount from the available balance. What is the output?
Cash.
Yes, cash amount. You want the amount, exact amount you are asking from the machine, right? Okay, in that way you have to decide the input, process, and output. Then try to complete all the activities here,
Okay, sir.
right? Uh, right here, giving some example. Then look at this one: AI chat box customer support. Right? That there are some companies, organization. I think you have some experience. Maybe uh, once you are working with that website, that automatically some agent appear as a chat.
Yes,
Right?
sir.
Then what are the input? If you want to get the support, then what are the input? Your problem, right? Your issue. Your issue is the input. Can you understand that?
Yes, sir.
Yeah, your issue is the input, right? Then chat box trying to solve it, right? They are checking there is there any solution in the system, right? According to based on your question, they are checking their system or their database to get the exact solution for that. Right? Once you get the solution, then it display right through the chat window, giving the solution. That's the output. Right? Is it okay that point?
Yes, sir.
Right. Okay. Like that. Complete this all the activities today itself after the class. It is better to complete it. Then after completing, then you can get a photo and upload your WhatsApp. Right. Then I can check
Okay,
it.
sir.
Right. Okay. Then look at the second question, activity two. Right. I think now you can answer this one. This is the question, exam type question. Right? This one is 2019 May. Computer are made up of both hardware and software components. Computer use a three-step computational models. Complete the diagram with the names of these steps. Right. Then straight, you can tell it now. 3 marks.
In,
What are the steps here?
in input,
Yes,
input,
input,
process, output,
process, and output. Input, process,
process,
and
output.
output. Right? Then in question paper, having this blank, on the blanks, you have to write down the answers. Right? Input that inside the cage, you can give in input. Then process, output. Right? That easily you can earn this mark, 3. Right? Then look at another year, 2023, question number 5. Right, now try to answer this one. Then take a piece of paper and write down the answer, inputs, process is already given there, output. Right, write down the answer and take a photo and try to upload.
Okay, sir.
Right, 2 minutes, right? Within 3 minutes, try to do that.
Okay, sir.
Yes, I think now the time is okay. 3 minutes is okay for this
Yes.
question. Right, try to upload your answer. Only one input is okay. 2 marks there, one for input and one for output. Try to,
I sent it, sir.
Input here, the direction, the B in facing north, and the number of steps.
Take.
Can't clear that one. Number of steps
Steps taken.
in yes. Output display the B in its new
This.
position. Yes, yes, correct. Right, one input and one output. That also you can say the number of steps that we can can forward. Number of steps that we can forward or that particular
Okay.
direction. Right, that output is okay. The new position of the P. Right, okay. I think you're having that knowledge, right? That easily you can catch up the inputs and output for the particular given situation, right? Uh, right, okay. Right now, before moving to the next part, then back into the again presentation. Right now, we can you see the presentation now in your computer also? Your
Yes, sir.
in the presentation. Now follow the presentation here. Types
Yes.
of hardware. Actually, the hardware meaning all the tangible devices in the computer. The things we can touch it. Tangible mean the things we can touch it, right? The physical existence there, right? That any way we can define it. The hardware, all the things you can touch or tangible things or physical, the things having the physical existence like that, we can identify the hardware. And this hardware may be either internal to the computer or external to the computer, right? This hardware exists internal to the computer. There are some hardware internal to the computer. There are some hardware you can find it outside the computer. That means external to the computer, right? Then here giving some list to the to the hardware: keyboard, mouse, microphone, joystick, like that. Some devices there. Then internally, also you can find the devices like CPU that earlier I mentioned, processor or microprocessor, another name for that, right? CPU, motherboard, RAM, sound card, modem, graphic cards, network card, like that. There are so many items available inside the computer also, right? That we are learning one by one. There are things in the outside and the things in the inside the computer. Right, that's the brief description about the computer hardware. Now moving to the next slide. Right, we are starting from the input and output devices that earlier I mentioned under hardware. There are lots of devices like keyboard, mouse, monitor, like that, right? The things outside the computer, we can categorize again two parts: input and output devices. There are some devices you can use to input the data, right? That earlier we learned the concept input, process, output, right? That process is followed by the computer. Therefore, there should be a way to input data to the computer. The input devices you can use to input the data, right? Once you input data to the computer, then processing thing happening inside. After processing, it will produce the meaningful information. To get the meaningful information, they need output devices or display the result, display the meaningful information, right? The computer use output devices. Right, here in this diagram says some devices like keyboard. Through the keyboard, you can input text, numbers, special symbol as data. Then camera there, digital camera. Through the digital camera, you can input moving pictures, recorded video. Scanners, through the scanners, you can input That means images, right? Textbook images, right? Like that, input devices in one hand, the other hand, output devices like printer, right? You can get your output through the papers, then you can use printer. Right? If you want to see the output through the through a soft copy, then you can use monitor, then speaker, right? That's sound output. If you want to input the sound, you can use microphone. Right. In that way, input and output devices you have to identify. Right. That definition of these input and output devices available in the note. Right. Here again, I am showing that one. Uh, Input and output devices you can find in the page number 5. Right. That definitions, examples, and the diagram is there. Right. Then moving to the next slide here. Yes, here activity again. This one is not the question paper activity. Name input devices that used to input the following data. Right, quickly write down the answer. Here in this case, having the space separately in your computer, through your computer, you can send it. Right. Here, special symbols, it's okay. Keyboard, images, camera is also okay. Take a picture and you can input it. Right. Camera or webcam, right? Both devices you can. A scanner is the best one, right? Through the specially designed for input the images, right? The best one is the scanner. Uh, if you are having this question in the question paper, then better to write down scanner, right? Webcam or camera is okay, but best answer is the scanner. The sound input micro, right? Okay, good. That the finish of this activity. Right, then moving to the next part. Right, then look at the screen here. Still, we are discussing about the hardware. When we are discussing about the hardware, we must discuss one particular concept, right? That is called von Neumann architecture. That's a very important concept in the hardware, right? We are not going to discuss in your according to your syllabus, not in deep, but simply you can understand what is about von Neumann architecture. Right. Then look at the some devices that here and there I am putting some devices. Input device, control unit. These are the devices that engage with the computer. Some devices input, that mean external to the computer. Some are out internal to the computer. Right. This von Neumann architecture explain how these devices are arranged internally. Right. How these devices are organized, right? How these devices are organized and how these devices are linked with each other. Right? Here that explaining under this concept. Right? Then another important part is this concept says about the memory. Right? That later you will understand again types of memories and in detail. That today itself I will start the memory part also. But up to now that you have some knowledge about the previous topics based on the previous topic, I think you know what is memory, computer memory,
Yes.
right? That earlier computers, that mean earlier mean first generation. Before the first generation, that means for the first generation computers, there's a concept, data and instructions are available separate memories. They are using separate memories for data and instruction. Right? One memory for data, another separate memory for instruction. But what Newman says, no need separate memories for data and instruction. We need only one memory for that. Data and instruction, all the things we can put in one memory. That's the main concept behind the one Neumann architecture. Right, there are two important things here I have discussed under one Neumann architecture. One is how organize the hardware devices internally. The other one, data and instructions are put in one common memory together. No need separate memory to put data and instructions. Right, that's the second important point under one Neumann architecture. Right. Based on that, then move to next slide. Right, here giving some description that uh, one Neumann architecture first proposed in 1945, John von Neumann. The still we are using this concept in the computer. Right, that's the important thing behind that. Right. Then second point, single memory for both instructions and data. That earlier I mentioned. Right, that's the second important point. Single memory for both instructions and data. That currently we say the main memory. I think you have some idea about that. Main memory or RAM, right? The single memory mean RAM or main memory when compared to the modern computers. Right. Then CPU consists of ALU, CU, and register. That first introduced that concept by the one Neumann, right? That we know that modern computers, the CPU having three parts for different performance: ALU, control unit, and registers. That later also we learn in detail. This concept is initially introduced by the one Neumann. It says that CPU consists of ALU, CU, and registers. Then also one Neumann explained the fetch, decode, execute cycle uses sequential execution, how instructions execute in the computer. There's a cycle there. Also, we should want to familiar with that cycle, not in deep, right? But we want to know in simply how execute the instructions. Right, that's the one Neumann architecture. Any question? Can you understand? Is it clear there? Can you hear me? Are you there?
Yeah, yes, sir.
All right, okay. Is it okay that one Neumann architecture? Is it clear that point?
Yes, sir.
Right. Okay. Then if you are having any question, then you can ask or you can send through the chat box.
Yes, sir.
Here, right, okay. That's the brief about the one Neumann architect. Here the most important is one Neumann says the arrangement of the devices internally, and he also point out the instructions. Right, then what the question, then chat box. All right, okay. I think now it's okay now.
Yes, sir.
Right. Okay, then moving to next slide. Right, then look at the architecture. That's the architecture that von Neumann explained. That earlier I saw the devices separately here and there. Now the internally, how arrange this internally. Right, that first get some idea about that. Not think about in detail, in deep. Input and output device available outside the unit. Right, this yellow color area is the system unit. And then inside the system unit, having this memory unit, one Neumann says this memory unit for both data and program. Right? Data and program. Then also one Neumann introduced the CPU, Central Processing Unit. Inside the Central Processing Unit, having three parts: control unit, arithmetic and logic unit, and registers. There are register types also. Right? Mainly four types. We are discussing about three main register types there later, but here to understand there are four main register types. Right, this is the way how the arranging the devices. always the input devices. That arrow is coming from input devices to system unit, right? Then through the from system unit to output device, then another arrow, right? This arrow from system unit to output device. No arrows from output to system, right? Then no arrows from the system unit to input devices, right? Then be careful about these arrows. Then look at the arrow, two arrows between central processing unit and the memory unit, right? Then central processing unit is able to access the memory, that this arrow meaning. Again, the memory can provide the details to the central processing unit, right? This arrow having the both side, right? Is it clear about this diagram?
Yes, sir.
Right. Okay. Moving to the next slide now. Right. Then try to answer this question now. Your time. Which of the following is a key characteristic of the one Neumann architecture? Right. Your answer is already sent to me. Single memory for both data and instruction. Right. It's correct. That earlier I mentioned it. Right. Single memory for both data and instruction. That's the correct answer. Right. Then moving to another activity. Here the exam type question. One Newman developed the stored program concept. Describe the stored program concept. 2 points there. Then two important points you can mention here. Right, earlier I mentioned there. Then write down the answer in yourself.
So is this about the memory?
Yes, that's what the two important point in the stored uh, program concept. That's another name for one Newman architecture, right? The same thing under one Newman architecture we discussed. The same thing about the, you want to write down about the stored program concept, right? But the two important point. The one is the arrangement of the internal devices, right? Arrangement of the devices internally. Arrangement of the devices
Oh,
internally. What are the devices internally?
okay.
CPU, memory. Mainly CPU and the memory. That's the first point. The second point,
Mhm.
data and instructions are in the single memory. Right? Both data and instructions should be in the same memory. That's the two important point you want to
Oh,
mention here. Right, write down it. Right. Arrangement of the devices, then within brackets say the main devices under one Neumann architecture, CPU and the main memory. Right? CPU and the main memory. Right, that's the correct answer. Then computer system and the data and instruction being stored in the same memory or single memory. Right, okay, that's okay. Then if you are write down in that way, then you can get the full marks, 2 marks here. Right, okay. Then before moving to the next one, then again back to the activity sheet. Yeah, right. Activity sheet.
Yes.
Uh, then try to answer this one. Again, exam question 2023 May. Right. Try to do this diagram in your piece paper in the book or somewhere and take a picture and upload to the WhatsApp. 3 marks here. I think 2 minutes. Okay.
So is the USB device connected to the CPU?
Here actually here think about the little bit thing. USB is the external storage device. The main memory getting data from the external devices. The main memory is not there here, but USB is working through the main memory. But in short, that you can think USB as the main memory. It's not the same, right? But
Okay.
for this question, you can think in the same way. Then you will get the
Okay.
correct answer.
So I sent my answer.
Right, okay, then we'll see it. Yes. Right, yes, your answer is correct. The CPU, speaker is output, arrow should be in the output way, right? Then always the input devices should give in the data to the system unit or CPU. This arrow should be in this. This thing like main memory. Always the CPU can access to the main memory. The data in the main memory can send to the CPU. Right, both way these arrows should be there. Right. Okay. Very good. That answer is correct. Now moving to the slide presentation. Right. I think next question also you can complete now. Right. Before moving to next one, here try to complete this one also. Just you can say it. No need to write down actually in here. Just say the device headset input or output.
Okay.
You have to mark a tick. Headset input to output.
Output. Output.
Yes. output, right? Headset, that music or sounds you can get through the headset. Output. Mouse, it's easy.
Input.
You want to tick on input. Printer,
Input. Output.
printer, output, right? This should be in the output. Touch screen,
Both.
both. The touch screen provide the feature both input and output. Your touch mean input, right? Through the so think about the smartphone. If you want to open the app, then you touch on that. Touch mean input. Then once you touch, it will open, right? Open and display to you. That means output. Therefore, touch screen is one of the device that showing both input and output features. Right. Okay. Then that's the question. I think questions are very easy, right? Not difficult. The difficult questions there, but most of the questions are not difficult. You can easily answer. Right. Okay. Now moving back to the presentation and move to the next slide. Right. Now we are going to start the part computer memory. Right. Up to now, what about you? Feedback? Is it clear the things? They
Yes,
need more
it's clear
explanation.
so far.
Right.
No, it's clear so far.
Right. Okay. Right. Now, computer memory. We are going to that earlier. We mentioned several times the memory like that. Right. Here, from that point, we are going to learn about what is memory. Right. There are types of memories. Right? Then each then function of the each type. That kind of things we learn. Right, then computer memory. Regarding the computer memory, once we discussed about the computer memory, there are two important concepts. Right? We should want to know these two concepts. The one is the capacity, the other one is the memory address. Right? Once you are discussing about the computer memory, you must know about what is computer capacity. The other one, you must know about the computer memory. Right, then get a little idea about the difference of these terms. Capacity. The capacity means how much you are going to store in the memory. Right? The capacity. How many data you can store in particular memory. That earlier I mentioned, there are different types of memories available. Right? There, there's a limit also. This memory. Right? No any unlimited memory capacities. There's a limit. Right here, look at the diagram here. It says some bits, bytes like that. These are called the measurements. Right? If the memory having a capacity, if you're having a capacity, mean there should be a way to measure it. Right? If you are having a capacity, then there should be a way to measure. Right? How you are going to measure the memory capacity is using this measurement like bits, bytes, kilobytes like that. Here the smallest element is bit. Right? The smallest elements to use measuring the capacity is bit. Bit one. One bit means space required to store one character or one digit. Right? One bit means space required to store one character or one digit. Right? One character means A to Z, one character, or one digit, 0 to 9. Space required to store one character or one digit. That is one bit. In based on that, they are making the other measurement. Right? That 8 bit called one byte. Right? 8 bit called one byte. There's sometimes it called as two nibble. That means the 4 bit they are assigned as the one nibble, another measurement, but not commonly used. Right. Then 1024 bytes. 1024 bytes, 1 kilobytes. Then 1024 KB, 1 megabyte. That's a pattern now that you can easily understand the measurement here. Right, then the conversion, you must be familiar with the conversion also. Then later we'll do
Yes.
some examples, then you will familiar with the conversions. Right, then when giving the gigabytes, then you want to say in kilobytes. When giving the terabytes, then you have to say in the megabytes or gigabytes. In that way, the conversion also available. Right. Actually, in the modern computers, not much going to that far. Only the terabyte. That modern computers having the hard disk capacity actually in the terabyte, not still in peta or exabytes. Modern computers now we are in the terabytes in that stage. Right. Now that's about the capacity. Then look at the memory address. Right. It's also important when you are consider a memory. This memory contain locations. Right? Memory is made up with the location. We are going to store data in that particular locations. This location, how you are going to identify this location is through the addresses. That is called memory address. Right. Then look at the diagram here. Right. In here, the memory is represented only in that area. Right. Then look at the area that I am moving the mouse. Right. Under data. Right. In that rectangle, represent the memory. Right. Then under that, the first location is a data. 1010 is the first data in the first location. This location, you can see under address. The first location is the 0. Right? 0 is the memory address, so memory location. In the position, in the location 0, store the data 1010. Is it clear?
Yes, sir.
Right. Then tell me in which place store the data 1101.
Uh, 2.
Yes, this 1101. This data is available in the 010. Right. Second location. The memory address is here 010. Right. If you consider the 1011, what is the place or location? The memory address
110.
110. Right. In that way, you have to get familiar with the data and memory addresses. That's the two separate things. Right. When you are representing in the same number system, memory addresses representing in binary numbers, data also representing in the binary address, binary numbers. Right. Don't mix up that one.
Okay,
Here, the separately you want to say the memory addresses and data. Not only now binary numbers, sometimes to represent the memory addresses, they are using hexadecimal numbers also. Right? Hexadecimal numbers they are using to represent the memory address. But data representing only using the binary numbers. Right. Remember these points, the details of these points available in the note. Then later you
yes.
can refer the note also. Right. Then moving to the next part. This next slides explain about the types of memory types. Then look at the diagram. Computer memory, mainly there are two types, internal and the external. Right. Under internal memory, there are again four types. Right? Internal memory, four types of internal memories there. RAM, cache memory, sequential access. Actually, it's not exact memory, but for that point, suppose that, assume that sequential access, then virtual memory and ROM. Here you want to remember in the examination point of view, it's important to understand the RAM, cache memory, virtual memory, and ROM. That's the four important memories you want to understand. The internal part of the memory, that another name for internal primary. Right? Sometimes some books says about the primary memory. Primary memory is the same as the internal memories. Right? External, the other side explain in the external memories. Right here, look at the right side of the diagram, external memories. Another name for external is secondary memories. Right? Example here giving solid state, magnetic, optical. Here actually giving the technology. Right? Technology they are using to store the data. And external memories, they are using magnetic technology, solid state technology, or optical technology to store the data. The devices use magnetic technology, mainly the hard disk. Here in the below that, uh, giving these examples also, optical technology mainly used by the CDs, DVD, Blu-ray. Magnetic technology, hard disk, hard drive, floppy disk, that kind of devices using the magnetic. Then solid state, normally USB memory, SD card, that kind of memories use the solid state technology. Right. We want to get a detailed idea about this memory structure. First, we are going to identify the internal part or primary memory. Right. Now we are moving to the discussion of primary memories. Right. Then look at the slide. First memory we are going to discuss the RAM. Right. Under computer memory primary part, the first one we are going to discuss about the RAM. Right. The RAM memory, RAM stand for random access memory. Random access memory normally available inside the computer in the form of cards, right? In this picture, giving the idea about the form or picture of the RAM available as a form of cards. Uh, Here, the main feature is the data is available temporarily, not permanent. The RAM is used to store the temporary nature data. Right? Data is available, only the power is there. Once you switch off the power, then whatever the data in the RAM will be vanished. Right? Not destroyed. Some part of the data destroyed. Some part of the data is permanently there. Permanently there means not in the RAM. Once you switch off the computer, the RAM is empty. No data. Right? There are some data that operating system data or package data available when you are working in the computer, the package and operating system data available in the RAM. Once you switch off, meaning all this data back into the proper places, but temporary data. Some part of data will be vanished or destroyed. Right? For example, suppose you are write down something in the word process. You are working with the word processing. You are writing a letter. Then suddenly power off. Then what happened? Can you tell me what happened? Once you suppose you are working in the word processing package, right? You are writing a letter. Suddenly power off. Then what happened?
The data
Yeah,
goes.
your letter is destroyed, vanish. Right?
Yes.
Whatever the content you are doing it with the word processing, it will be vanish. But the word processing package back into the proper place. That means to the hard disk. Right? Word processing package, then operating system data, all of these things are back into the proper place. Right? Then power off means no data in the RAM. That's why it says temporary. Right? Temporarily data available in the RAM. Right? Another name for that volatile. Right? No data. That once you power off, the data is back into the proper places. Some part of the data will be vanished. That means volatile memory. Right. Then remember these points. Then another point there in the last one, CPU decides the memory location that used to read and write. Right? That memory location, memory address that earlier we identified. Right? This memory location, the CPU is decide the memory location where to write the data. right? Then how data read from the RAM? The CPU decide that, right? Then regarding the capacity, normally having 1 GB, 2 GB, 4 GB in that pattern, right? The RAM capacity is available in that pattern. 1 GB, 2 GB, 4 GB. Then you can guess the next one, 8 GB, then 16 GB. Right? In that pattern, having the capacity with the RAM. Right. That's the things about computer RAM. Uh, Another name for main memory, normally referred as memory. That sometimes some people says memory, right? That normally that suppose you are going to purchase a computer, right? From the shop, you are asking that shop owner, what's the memory of this computer? That means you are asking the RAM size, right? Then some people say main memory, another reference, the main memory, right? That exactly correct name is RAM, random access memory, right? Then moving to the next part, right? Before that, again question, right? Try to answer this one. Which of the following best describe the function of RAM in a computer system? Uh, Try to give the answer. Right. Now you answer with me. Says it provides temporary storage for data and instruction currently in use. Right. That's the exactly correct answer. Right. The next one. Right. Before coming to that part, another activity you want to complete. Back into the activity sheet now. Right. Open the activity sheet again. Right. I think it's already open. Move to the activity 5. Not 5. That already completed that one. 6. Uh, Sorry. Here, explain one reason why computer need both. Here, the ROM that we should want to complete the ROM part. Then we can back into the activity. Right. Okay. We are complete that part and coming back to the question. Right. Right. Move to this one. Slide presentation again. Computer memory. That's the second type of memory we are going to discuss. The ROM, read only memory. The first one, RAM, random access memory. Here the second one, read only memory. Again, available in the inside the computer, fixed on the motherboard as a chip. Right. In the diagram says that how ROM is fixed in the computer motherboard. Right. In this diagram, you can see here in the below the bottom diagram is the separate RAM. After removing the ROM from the motherboard, you can see like that. It's a somewhat older one, not the modern ROM. But in the that above diagram is the modern one. Right? That's the way how fix ROM to the computer motherboard ROM. Right. Then look at the features of the ROM. It says the permanent memory. That earlier one, temporary. The permanent mean the data available in the ROM used for its lifetime of the computer. Right? That's why it says the permanent data. The data in the ROM normally feed by the manufacturer. When the manufacturing computer, time of manufacturing the computer, manufacturer feed data to the ROM, feed only memory. Right? Another meaning they are non-volatile. That means you can't access, you can't delete the data in the ROM. You can't save your data in the ROM. You can't access. You can't not allow permission, not giving permission to access the data in the ROM. That's why non-volatile. Right. Then look at the next point. that earlier I mentioned, when the time of manufacturing the computer manufacturer feed data to the ROM. That's a specific program. The manufacturer feed or save specific program with the ROM. That is called BIOS, Basic Input Output System. That's the most important program in the computer. Once you switch on the computer, the first uh, program to start the activate is the BIOS. Right? BIOS is the first program to activate once you switch on the computer. Right. That later you will learn the functions of the BIOS also. That's the for to now. Remember, there's a specific program in the ROM called BIOS. Right. Then ROM you can find as a chip that earlier I mentioned, but you can't remove it. In yourself, it needs specific lab. If you want to update the ROM, it needs specific lab yourself. You can't update it. But RAM, that earlier memory, you can in yourself you can update easily update. But from chips you can't easily update. Users are not allowed that earlier I mentioned that feature in the time of manufacturing the computer, manufacturer feed data. These are the specific feature regarding the ROM. Is it clear that part?
Yes, sir.
All right. Okay. Now moving to the question. Activity 6. Here also to 2024 May exam, question number 2B. Right now, write down in your book, write down the answer. I think this one is, wait, before giving the answer, wait. Right, the first write down this, giving the answer, this MCQ one. Which of the following best describe the read-only memory? Right. Here you gave the answer. It retains data even when computer is powered on. Yes, that's correct. That's the correct answer. Even power off the computer, all the data in the ROM will be keep retained its lifetime. Right. Uh, Next one. Right. Giving the answer for this one is MCQ type 2023. It's exam question. Identify what is stored in ROM. Very easily you can say. Yes, the basic input output system, in short BIOS, right, available in the inside the ROM, read only memory. Right. Right now, the question that earlier I showed that question in the activity sheet, but in the presentation here also available that question. Now write down the answer. The separate space available through the computer. You can give in the answer. Right here. the answer, RAM is needed to store temporary data and information in the computer. That's correct. 1 mark for that. Then while ROM is needed to initiate the booting process of it's okay. But what's the name of the program that initiate the booting process? Then within bracket, you want to say that
BIOS.
one also. BIOS, right? Initiate the booting process. In that point, within bracket, say BIOS. Bias that if you are saying the bias that while ROM use the BIOS program to initiate the booting process. Right. Okay. This name should be need for that answer. Basic input output system. Right. Okay. Then exactly these terms is needed, right? When you are write down the answers, that the examiners are very careful about these terms. Right? If you are missing that you know that I know you know what is RAM, the functions of the ROM, right? But when you are write down the answer, that missing that word bias, right? That
Okay,
means
sir.
that 1 mark is missing there. Right. Okay. Is it clear that okay? Is it understand?
Yes, sir.
Right. Okay. Then that's about computer ROM. Up to now, we are discussing about the computer memory. Uh, Memory is divided into two parts, internal and external. We are discussing about the internal memories. There are four types of internal memories. First one RAM, second one ROM. That already we discussed that part. Then we should want to discuss about the cache memory, the third one, and the virtual memory, the fourth one. Right. Moving to the next slide. Here, explaining about the cache memory, computer cache memory. Right. Normally, the cache memory is available uh, in the computers to improve the speed. Right. To improve the speed. How the computers can improve the speed is normally that the data very often used. Right. Data very frequently used data that CPU can keep it very close. The CPU is the brain of the computer that earlier I mentioned. Right? The CPU having the data very close to it, then CPU is able to finish that work very quickly. Right? Suppose you are going to do some work, you are suppose you are going to draw a picture. Right? Draw a picture. Then suppose your tools that need to draw in the picture are somewhat far from you. Then what happens? You want to go to that place, then take the pencil, then draw in the diagram. Then after that, you want to again go to the tracks and get the colors and come back and color the picture. Then what happens if your tools are very close to you? Your pencil is there, then your color box is on the table. Then what about the speed of finishing the drawing? Hmm? Can you think that you can quickly finish your drawing if you are having your tools very close to you? The
Yes.
same concept followed by the computer also, CPU. Right? What CPU doing is the frequently used data keep very close to the CPU. How you are going to keep this frequently data used data is through the cache memory. Is it clear that point?
Yes, sir.
Right. That cache memory is used to store frequently used data. Right. It support to improve the speed of the computer. The CPU can easily access to their close memories. Right. Then suppose no cache memory in the computer. Then how the CPU find in the data? CPU have to access to which memory to find in the data if you are having no cache memory.
The RAM.
RAM, main memory. Right? Always the CPU has to access the RAM. Right? Then that means the RAM is somewhat far from the CPU. Right? CPU has to uh, run some distance to get the data. But the cache that what cache is doing, the cache is located very close to the CPU. Then CPU no need to run away far from the there. The CPU easily catch the data from the cache. Right, that here explaining that these things designed to store frequently accessed data help reduce time needed to fetch data from the main memory. Right, uh, that's the features of cache memory. Uh, then another thing, the place the cache memory normally situated that earlier I mentioned close to the CPU. That exactly where close to the CPU. There's some cache memory available inside the CPU. Some cache memories part is available outside the CPU, but very close to the CPU unit. Right? There are two types of cache memories. Actually, three types of cache memories. That another slide explain that. Then we'll see the things available in the next slide. Yeah, look at the diagram here. Try to understand this diagram. The cache memory is between CPU and main memory. That earlier I asked one question. If not cache memory, then CPU has to access directly to the main memory. Right. Then they are introducing the cache memory. That means frequently used data now keep in the cache memory. Easily CPU can access to cache memory to process the instructions. Right. That's the way how the cache memories work. That's this diagram explain. That earlier I mentioned the types of cache memories. Here there are three types: L1 cache, L2 cache, and L3 cache. The L1 cache is the cache available inside the CPU. Right? Then L2 is the cache available inside or very close to the CPU. Right? Outside the CPU, but very close. Sometimes the L2 also available inside the CPU. That depend on the computer mother. Right. Then L3 cache, another type of cache available in the modern computers, shared among the multiple CPU cores. Right now, you know that latest technology that multi-cores, the same one CPU, but divided into parts. That one part is known as the cores. Right, dual core. In that way, there are core numbers there. Right? Each core is having the cache. Right? If you are having the cache in the cores, that is called L3. Right? Shared among the multiple CPU cores. Is it clear that point?
Yes, sir.
Right. Here explain about the types of cache L1, L2, and L3. This diagram explained about the location where the cache memory is available. Right. Okay, then move to the next part. I think it is activity. Yes. Try to answer this one. Right. The main purpose of cache memory. Here given the you answer temporarily store frequently accessed data for faster processing. Yes, that's the correct answer here. Right. Try to answer this one now. It's a exam type question 2024 May question 2B. Right. Then first try to yourself. Right here, your answer is available now. Still writing, no? Right, complete it. Right.
Okay, sir.
Right. By increasing the size of the cache memory, the CPU is able to store larger amount of frequently used data. That's the point here. Size, amount or capacity, large capacity mean it allows to store more frequently used data, right? That means CPU can execute instructions very fast, right? Processor fast. Right, okay. Here the answer is correct. Right? 2 marks allocated for that type of questions. Right. Now moving to the next part. Right. Here the fourth one, virtual memory. Another type of memory, again primary or internal part of memory. Right. Already we discussed about RAM, ROM, and cache memory. Here the last uh, primary type of memory, virtual. The virtual, actually virtual mean not really available, exactly physically not there, right? Not physical existent. That RAM mean the physical existent there as a card, as a form of card. The ROM also physically exists as a form of chips, right? Cache memory also as a form of chips, right? Physically exists. But virtual memory is not physically exist. Right? It's virtually created. Right? According to the requirements, the virtual memory is virtually created. Normally, the virtual memory is created in the hard disk. Right? Why the virtual memory is created? Because of the bottleneck. That look at the point here. Why the bottleneck happen? RAM is full. Right? If suppose if you are having a small RAM, small RAM, then you need to store your operating system, then package data, your temporary data, all of this in the RAM. Right? If you are putting all of these things with the RAM size is RAM become full. Then again now able to get in another set of data to the RAM. That means the computer may be stuck from that point, right? Because the RAM is full. Then what's the solution? No RAM. That earlier computers having no virtual memory concept, the RAM is once the RAM is full, the computer is stopped. That errors, that bottlenecks there. To solve that problem, the computer scientists introduced the virtual memory. Right? They are giving the concept to create the RAM-like memory in the hard disk. How they are doing that? By swapping the data. Right? The RAM data, once the field RAM is full, then the RAM's data back into the hard disk. That's a separate place in the hard disk. Swap this RAM data, some of the data, not all, some of the data swap to the virtual area of the hard disk. Right. Then the RAM is okay, that some data are moving to the virtual memory part. Now the RAM is available again. Another set of data now you can send to the RAM. Right. After finishing that work, again that earlier set of data again back to the RAM from the virtual memory. Right. Uh, this way called the data swap back and forth between RAM and hard disk. How the virtual memory is created in the hard disk, right? By swapping back and forth RAM data, by swapping back and forth RAM data with the hard disk, that particular area of the hard disk. Is it clear that point?
Yes, sir.
Right. That's about the virtual memory. Right. Then moving to the next slide, try to answer this one. What is the primary purpose of virtual memory in a computer? to use secondary storage as a temporary, your answer is to use secondary storage as temporary RAM when physically memory is full. Yes, that's correct answer. In this case, the secondary storage is here. It must be hard disk. Okay? It's not allowed to create in virtual area for pen drives, CDs. In that type of secondary devices, they are not allowed create in the virtual space. Only the hard disk is allowed to create in the virtual space. The secondary storage means here the hard disk uh, as temporary RAM when physical memory is full. That here the memory mean RAM, right? Physical that earlier I mentioned there are some references that the memory mean RAM or main memory RAM, right? All of this reference for the RAM memory. Right here, your answer is correct. Answer is A here. Right. Then look at another. I think another activity. Right. It's not the activity here. Our next part is the central processing unit. Right. That we are discussing about the memory. There are four types of memories we are already identified: RAM, ROM, cache memory, virtual memory. Right. That from that point, I'm start the central processing unit because inside the central processing unit, again, there is a small memory. That's also under primary. That's the fifth one. Right. That I think in the memory hierarchy that earlier I show you the diagram. In that diagram that earlier that I mentioned the sequential memory, small memory there that
Yes.
I pointed out that one. That small memory is available inside the CPU. That is called registers. Right? The name is the register. Right. Here we want to get the idea about the purpose of having small registers here also. Therefore, better to discuss the central processing unit before moving to the external memories. Right? Before moving to the external memory. From that point onward, we are discussing about the concept of memory. Sorry, concept of CPU, Central Processing Unit. Right. Again, it's a kind of chip that the diagram you can appear the left side of the slide. In the form of chip, you can fix into the motherboard of your computer. That's the most important part of the computer. Right? That's the brain, like brain, that human brain that earlier I mentioned. Whatever the task you assign to the computer, total responsibility of doing that task taken by the CPU, Central Processing Unit. Right. Then there are three elements to support CPU to perform the task. That means CPU having three main elements called ALU, registers, and control unit. ALU actually stand for arithmetic and logic unit. It responsible to perform all arithmetic and logical operations. All arithmetic and logical operation. The other two parts is registers and control unit. Right. That's the basic features of the central processing unit. Right. Then look at the second elements, registers. That earlier I mentioned, small kind of memory, very small. It measured in kilobytes or KBs. Normally, memory is measured in megabytes, gigabytes, right? That type of very large capacities. But registers normally measured in kilobytes. But the important type of register, right? The computer speed controlled by the register. Normally, the computer speed, do you know the 2.2 gigahertz like that? You heard about the computer speed, that 2.2 gigahertz. 1.9 gigahertz. That speed controlled by the registers. Normally in the CPU having three types of registers. Right? Actually four types, but according to your curriculum, they are given only three: accumulator, program counter, and current instructions. Right. In this is the only introduction here. Read out these the type of registers. Normally accumulator used to store the result of the calculation. Program counter normally used for contain the address of the next instruction. Current instruction register used to store the instruction of currently working on. Right. I think you can't understand that thing by looking at only by looking at this slide here and my explanation, little explanation here. Right. You need more explanation to understand the perform of registers. It leads to the fetch decode execution cycle also. If you want to understand this cycle better, then you want to understand the purpose of this register source. Right here, actually, our now reaching to end of our session. Therefore, no time to discuss in detail now about the registers and other things. Therefore, I'm going to stop the session for today. Right here, that what about in your point of view? Then tell me the feedback. Is it okay or any other doubts or any questions? Then you can ask.
It is clear, sir.
Right. Uh, the speed. What about the you want to do it in somewhat slower than that too? Or
Oh no, it's
it is
perfect, sir.
okay. This way is okay.
Yes, sir.
Right. In method of doing our lesson is in that way. Right. Every week I'm using that kind of interactive presentations. Then you also can involve actively for the questions. Uh, right. Then the presentation slides also I'm giving to you with the notes and the activity sheet. Right. All the necessary resource I will be provide through your WhatsApp number. Right, okay, then I'm going to stop it here. Then our time is fixed every Friday, 6 to 8. Right, okay, thank you very much for the participation.
Thank you, sir. Bye, sir.
Right.